In this video, I'll be showing you how you can install SQLite database on your operating system. So what is SQLite? SQLite is an open source embedded database. By embedded, I mean it doesn't require any server in order to communicate with that database. You can directly create your database on your file system of your computer and then directly communicate with it without any server. Many Android applications are using SQLite to store the data locally on your Android device and fetch the data required by the application. So let's see how you can download it. Just open your favorite browser and you can simply search for SQLite. You can see the first link, which is sqlite.org. Just click on that and you can see that the website opens. Now just go to the download section and here you can see there is a list of available downloads for this, but I will scroll down and let's search for pre-compiled binaries for Windows. You can see that there are 3 links available. We'll go for the third one. It's a zip file. So we'll download this and let me extract this on my desktop. You can see it is downloaded. So let's extract this. Yeah, so it is extracted. Now you can see that there are 3 files, the 3 executable files. The important one is the middle one, which is SQLite 3. So in order to create a database, you need to make this available on your entire system so that you don't have to open this again and again. So I'm going to add an environment variable. So just press the Windows and search for system. You can see edit the system environment variables. So I'll just copy this link and I'm going to append it. So you can see environment variables. Just scroll down in the system variable section and add it to the path variable. Yeah. So I've appended this. Click OK. So let's test our database. Just open the command prompt and just type SQLite 3. So as you can see, on typing this, I'm getting SQLite version 3.2.7.2. This shows that it is correctly installed.
Hello everyone. Now, as the installation part is done, now we have 2 options to create a database. That is one using GUI and one using shell. That is our command prompt. Let's see how to create a database using a command prompt. Just open your command prompt. Change your directory to the desktop. Let's create one folder for our database. Again, go to the database. Let's change your directory. Now you have to type SQLite 3 and the name of your database. Suppose it is college.db. So our database is now done. Let's create a table. For that we have to use this create table command. It's create table plus table name. Suppose the table name is student, and you have to specify the column names with it and the data types of that table columns also. Suppose there is a name, which is a varchar. Then there is student ID, that is SID. is a friend, and then there is a year, that's I mean the first year, second year, like that. Just make it varchar again. And then we have to specify primary key of our table. In this case, this is SID. Now our table has been created. To add the data in this table, there is one command known as insert. Insert into table name, which is student, values, and you have to put all the values you want to fill in this database. First is name. You have to add the varchar part in the single quotes. It is Prachit. And then there is SID, and this here is suppose SY. Done. Oh, forgot single quotes. Yes. Similarly, you can add another records also. You have to make sure you don't duplicate the key again. That is, primary key is unique, so you cannot use the same key again for a different record. So make sure you don't do it. Suppose it is Kalpesh name. Done. Then there is Rahul M. Now, to see what the table contains, we can use select command, select star from table name, which is student. In this case, star works as all the columns. Like if you have to select only name, you want to show only name, then you can write select name from students. Okay, we are getting our table. Select name from students. In this case, I will just get the names. Okay, now let's move ahead. Suppose I want to add another key in the table, then we have to alter the table. That is, you have to use alter table command. Alter table student, and then you can write add column. There are different commands like delete column, add column and all. And oh, there is no add, just have to mention the name. Suppose it is roll number, and then end. Please show error. Okay. Okay, nice, done. So if we see, now there is no number in that roll number column. So to update the table, that is to update the data we have provided to the table, we have to use update command. That is update, then table name, then set, and we have to write the column name here, that is roll number, equal to, suppose the roll number is 1, and then we have to provide it the condition, that is where SID equal to 100. Done. Now if we try to read the data from table, from student, see there is the roll number added to our database. Now similarly, we can delete some records from our database, that is delete from table name student, and we have to provide the condition for this, that is where where SID is equal to 101. Now if we try to get the data, let's start from students. See, the second entry has been deleted. Similarly, we can delete the entire table with the drop command, that is drop table and table. Yeah. Now if we check for the tables, it will show no tables. See, there are no tables available on our database now. The reason behind using this shell is that using shell is very handy. Like, you don't have to click, you don't have to find the various icons for creating table, deleting table, creating new rows. So that is the main advantage for a programmer to use this shell for creating a database. So that's it.
So now that we have seen the installation part of SQLite and used the command prompt to create a database, but there is a much better way to create database, which is using the SQLite database browser. The database browser for SQLite is a high quality open source tool to create, design and edit database. So now I'm going to show you how to download this tool. So open your browser and just search for SQLite database browser. You can see the first link, which is DB browser for SQLite. So just select that one and just go down to the download section, and as you can see that there are list of available downloads. I'll go for the second one, which is DB browser for SQLite, which is a zip file for the 32-bit version, because my PC is a 32-bit version. You can select as per your operating system. So let's click on that. Save. Just open this zip file and extract it on your desktop. You can see it is extracted. You can see the folder, and just scroll down and you can find database browser for SQLite. There are actually two application folders over here, but we'll select the second one, which is DB browser for SQLite. Now you can see that the dashboard opens.
So this is how the dashboard of database browser looks like. On the left hand side we have the database schema. Over here in the middle we have several other options, one of which is execute SQL, which we are going to use repeatedly. This is the place where we are going to type our SQL queries and execute them. So now before we start with a database, we need an ER diagram for it. So over here I've googled an ER diagram from the internet for the company and I've even downloaded the image. So let's have a look towards it. So we can see we're going to need several tables as we have many entities over here, which is employee, department, project, dependent, works on, etc. So let's start with it. So let's go to new database to create a new database. Select a location to store your database and give it a name. For example, I would like to give it as company.db. Make sure that the extension is .db or any one of the ones which have been specified over here. Let's click on save. So the new database has been created. Now let's go to execute SQL, and now we're going to type some basic queries to create tables and perform certain operations. So first we would create some tables. Alright, so over here I've written down a query to create a table with name, department, and it has certain attributes such as dname, bnumber, manager, assistant manager, start date. The number has been selected to be the primary key. So let's execute this query. Alright, over here at the bottom it says that the query has been executed successfully. Also on the left hand side we can see that the table with name, department has been created successfully. Next, let's create a database. Let's create a table with name employee. So over here, I've written down a query to create a table with name employee. It has several attributes, one of which is SSN, which has been selected to be the primary key. The DNO is a foreign key which references department D number. So let's execute this. And it says that it has been executed successfully. And also on the left hand side it can be seen that the table employee has been created successfully. Next, there's a better way to create tables. That is, for example, you can go in edit, click on create table. Let's say we want to create a table with name, department, location. We want to add certain fields to it. For example, the number, we want it to be an integer, we don't want it to be null. So we'll click and check the box under n, which stands for not null. Along with that, this will be a foreign key which will reference the D number in department table. So yeah, department, and then it references D number over there. The second field that we want to give is the location, which will be of data type, and let's give it a length, let's say 20. We don't want it to be null, and we want both of them to act as a primary key. So yeah, everything looks good and okay. So yes, the query was executed successfully, and hence we have successfully created a table with name, department, location. So I'll just quickly create a few more tables and then we'll begin a few operations. And yes, we have successfully created a table with name project. Next, we have a table with name works on. Let's execute this one. And yes, the table has been successfully created. Next, we have a table with name dependent, which stores the details of the dependents of the employees in the company. So let's execute this. And yes, we've successfully created the table with name dependent. So we've created a few tables over there. Next, let's insert a few values in it. For example, let's input some random values into the department table. Over here, I'm inserting the name of the department as research. I'm giving it a number as 5, etc. Now let's execute it. And yes, the query was executed successfully, and hence we have successfully added it to the table department. We can see this over here in the browse data section. Yes, we can see that the tuple has been successfully added, where research is the name of the department, 5 is the department number, this is the social security number of the manager, and this is the date when the manager started or moved in as the manager of the department. So let's input another value into the department table. Let's say this one. Let's run it. So yes, even this query was executed successfully. And let's check it over here. Okay, the value has been added in here successfully. Over here, if you click on new record button, it gives you an option to manually manipulate or enter records into the table. For example, we can try over here, let's say customer care department. Let's keep the number as 6. Let's give it as 003 and joining date as alright. So even this is a better way to insert values or tuples into the tables. Let's get back to the execute SQL. So let's insert some values into the employee table. So let's insert this tuple into the employee table. And yes, it was executed successfully and has been added to the table employee. Let's input some more random values. So if you go back in browse data and change the table to employee, you can see that the values have been added successfully. Again, if we select new record, we can manually input values over here. All right. So we're going to again insert a few values into the other tables. So if you go to the browse data, we'll see that the tuples have been added into the respective tables. This is the department table, the dependent table, department location table, the employee table, the project table, and works on table. This was all about some basic data definition language commands. So let's execute a few DML commands, that is data manipulation language commands. Now, update is a DML command which is used to update the tuples in a table. Now suppose we want to increment the salary or change the salary of an employee whose employee ID is this. So let's execute this. Before that, the current salary of the employee with this ID, that is employee EMPSSN001, is 50,000. So after we execute this query, and the query has been successfully executed, the value has been updated to 75,000. Next, we're going to use the delete command. Now, if you want to delete a particular tuple from a table, we use the delete command. Now, suppose we want to delete an employee with this ID from the works on table, we execute this query. Before we execute that, you can see that in the works on table, the employee with the social security number, that is EMPSSN004, works on the project number 1 and for 6 hours. So after we execute this query, it can be seen that the table has been updated, that the employee with this ID has been deleted. The next command is used to display the first name and the last name of all the employees who work for the department with department number 2. So let's execute this query. Employees, that is Sophie Turner and John Snow, who work for the department number 2. And we can move over here. Let's say employee. Yeah, you can see that there are these 2 employees work for department number 2. Next, if you want to know how many number of employees work for each department, we're going to use the count function which counts the number. So let's execute this function. This query is going to return the number of employees, those who work in H department. So let's execute this. And over here, so we have 2 employees who work in administration department and 2 workers who work in research department. So this was all about using a database also to create a database. So I hope you like it, and thank you.
So let's see the features of SQLite. It is serverless. Normally, an RDBMS such as MySQL, PostgreSQL, etc. requires a separate server process to operate. The applications that want to access the database server use a TCP/IP protocol to send and receive requests. This is called as a client-server architecture. So as you can see, this is the client-server architecture for other RDBMS tools like MySQL. But that is not how SQLite works. It entirely works without a server. SQLite database is integrated with the application that accesses the database. The applications interact with the SQLite database, read and write directly from the database files which are stored on the disk. It is self-contained. SQLite is self-contained means it requires minimal support from the operating system or external library. This makes SQLite usable in any environment, especially in embedded devices like iPhones, Android phones, game consoles, handheld media players, etc. It requires zero configuration. It requires zero configuration because of the serverless architecture. You don't need to install SQLite before actually using it. There is no server process that needs to be configured, started, and stopped. In addition, SQLite does not use any configuration files. It is transactional. All transactions in SQLite are fully ACID compliant. It means all queries and changes are atomic, consistent, isolated, and durable.